Right now, 93 million miles away, a ball of hydrogen and helium is holding Max's entire life together. It keeps him warm. It keeps him fed. It keeps this planet from flying off into the void at 67,000 miles per hour. And in this video, we're going to turn it off. Not slowly, not in a billion years when it actually runs out of fuel. Right now, instantly. One moment it's there, the next it's gone. No warning, no explosion, just gone. Cosmo doesn't seem concerned, but Cosmo also ate a crayon this morning, so let's not use him as our emotional barometer. What happens next is one of the most fascinating thought experiments in all of physics, and it starts with the scariest 8 minutes you've ever experienced. The sun is 93 million miles away. Light, the fastest thing in the universe, takes about 8 minutes and 20 seconds to cover that distance. That means right now, the sunlight hitting your face is already 8 minutes old. You're not seeing the sun as it is. You're seeing where it was 8 minutes ago. So if the sun vanished this very second, nothing would change. Not for 8 minutes. You'd still see it in the sky. You'd still feel its warmth. Birds would keep singing. Traffic would keep moving. Max would keep petting Cosmo. Nobody would have the slightest clue that the source of all life on Earth had just ceased to exist. For 8 minutes and 20 seconds, we'd be living in a ghost story, warmed by the light of something that no longer exists. And here's what makes it even weirder. It's not just light that takes 8 minutes. Gravity does too. Einstein showed that gravity travels at the speed of light. So for those 8 minutes, Earth would still orbit normally. The gravitational pull of a star that isn't there anymore would still be holding us on course. We'd be orbiting nothing, following the rules of a game that's already over. That might be the most unsettling part, not the disaster. The delay. The universe lets you keep going for 8 more minutes like nothing happened. And then it collects. Minute 8. The last photon arrives. The sun winks out. Not like a sunset. There's no gradual dimming, no orange horizon. One frame it's there, the next frame it's a hole in the sky, just stars where a star used to be. And it's not just the sun that disappears. The moon goes too. The moon doesn't make its own light. It reflects sunlight. No sun, no reflection. The moon becomes invisible, just a dark circle blocking the stars behind it. Max is standing outside. 1 second, the sky is normal. The next, black. Every star suddenly visible at once. The most beautiful, terrifying sky anyone has ever seen. Cosmo doesn't notice. Cosmo is sniffing the ground. The ground is always interesting when the universe is ending. If you were on the night side of Earth when this happened, you wouldn't notice the visual change at all. You'd look up, see the same stars, the same sky. For you, the first clue would be something much more subtle. The temperature. Earth's surface temperature averages about 59 degrees Fahrenheit. That's not because of the atmosphere alone. It's because the sun is constantly pumping energy into the system. About 173,000 terawatts of solar power hit the Earth every second. Take that away and the planet starts cooling immediately. Within the first hour, you'd feel it. Not dramatically, maybe a few degrees. Like a chilly evening. Max grabs a jacket. Cosmo doesn't need one. He's a golden retriever. He was built for this. Within the first day, temperatures would drop noticeably. Most places would feel like a cold winter night. Max can see his breath. Cosmo thinks the frost on the grass is a snack. Within the first week, the global average would plunge below 0 degrees Fahrenheit. Rivers and lakes would begin to freeze. Cosmo tries to walk on a frozen pond. It goes exactly how you'd expect. Within the first year, we're looking at minus 100 degrees Fahrenheit or worse. That's colder than Antarctica's harshest winter. The oceans would start freezing from the surface down. A layer of ice forming across across every body of water on the planet like a lid on a pot. But here's a detail that surprises people. The oceans wouldn't freeze solid, not for a very, very long time. Water is incredibly good at holding heat, and the deeper you go, the more insulated it is. The ocean floor would stay liquid for potentially thousands of years, warmed by geothermal heat from Earth's molten core. And that's not nothing. That's a lifeline. But let's rewind to minute 8 one more time, because the darkness isn't the biggest problem. Gravity is. The moment the sun's gravitational influence reaches us, 8 minutes and 20 seconds after it vanishes, Earth is suddenly untethered. There's nothing holding us in orbit anymore, and an object in motion stays in motion unless something stops it. Earth has been orbiting the sun at about 67,000 miles per hour. Without the sun's gravity bending our path into a curve, we'd continue in a straight line, not spiraling, not falling, just leaving. A straight shot into interstellar space at 67,000 miles per hour. Max looks at Cosmo. "We're moving, buddy." Cosmo's tail wags. Cosmo loves car rides. This is just a really, really long car ride with no destination and no gas stations and no coming back. The moon would stay with us. It's bound to Earth's gravity, not the sun's directly. So we drift through the void as a pair, Earth and its moon, a frozen rock and its silent companion, sailing into the dark forever. And we wouldn't be alone. Every planet in the solar system would do the same thing. Mercury, Venus, Mars, Jupiter, each one flung off on its own straight-line trajectory. The solar system wouldn't collapse. It would scatter like billiard balls after a break, except nobody's at the table anymore. The entire neighborhood just evicted. Now here's the question everyone asks. Could we survive? And the answer is more optimistic than you'd think. Not everything's fine, optimistic, but humanity is annoyingly resilient, optimistic. First, photosynthesis stops immediately. No sunlight, no plants. Within weeks, the base of the food chain collapses. Agriculture is over. Every farm, every greenhouse, every crop field, done. But humans aren't just farmers. We're engineers. We have geothermal energy, nuclear power, and stored food. Nations with nuclear reactors and underground infrastructure could, in theory, create sealed, heated environments. Think of it like a permanent submarine mission, except the submarine is a bunker and the ocean is the frozen surface of Earth. Max would adapt. He'd build something. He always does. Cosmo would adapt even faster. Cosmo doesn't need sunlight. Cosmo needs a warm spot, food, and someone to rub his belly. As long as the bunker has those 3 things, Cosmo is fine. Cosmo has been living in his own personal universe this whole time. The sun was background noise. Iceland, weirdly, would become one of the best places to be. It already runs almost entirely on geothermal energy, heat from the Earth's interior. That heat doesn't care about the sun. It comes from radioactive decay deep in the core, and it'll keep going for billions of years. And here's something beautiful. Life at the bottom of the ocean wouldn't even notice. Hydrothermal vents on the ocean floor support entire ecosystems. Worms, shrimp, bacteria that have never seen a single photon of sunlight. They run on chemical energy from the Earth itself. To them, the sun was always irrelevant. They've been living in a sunless world this whole time. Cosmo and the tube worms, both completely unbothered by cosmic catastrophe. Different reasons, same energy. So even in the absolute worst case, sun gone, surface frozen, humanity scrambling, life itself would carry on. Deep in the ocean, in the dark, right where it started billions of years ago. But let's zoom out even further, because Earth's journey doesn't end just because the sun is gone. We'd be drifting through the Milky Way at 67,000 miles per hour. That sounds fast, but space is incomprehensibly empty. The nearest star, Proxima Centauri, is 4.24 light years away. At our current speed, it would take about 43,000 years to reach the nearest star system, and we'd almost certainly miss it. Space is three-dimensional, and the odds of drifting close enough to another star to get captured by its gravity are astronomically small. Earth would become a rogue planet. And here's here's the wild part. Rogue planets aren't rare. Scientists estimate there could be billions of them in our galaxy alone. Planets without stars, wandering through the dark, ejected from their home systems by gravitational chaos. We'd just be joining the club. Max looks out the window of the bunker. Nothing but stars drifting slowly past. No sun, no destination. Just the quiet hum of a nuclear reactor and the sound of Cosmo snoring in the corner. It's the loneliest road trip in the history of the universe. But they're together, and the heater works. And over millions of years, as Earth drifted, something strange might happen. The ice on the surface would actually become an insulator. Beneath miles of frozen ocean, liquid water could persist for an incredibly long time, kept warm by Earth's internal heat. A frozen world on the outside, but still alive on the inside, like a cosmic snow globe with a warm core. Now, let's step back from the disaster for a moment. This entire scenario is, of course, impossible. The sun can't just vanish. Conservation of energy won't allow it. Stars don't disappear. They evolve, expand, and eventually fade over billions of years. Our sun has about 5 billion years of fuel left. It's middle-aged, stable, reliable. It's not going anywhere. But the reason physicists love this thought experiment isn't because it's realistic. It's because of what it reveals. It shows that gravity travels at the speed of light, something Einstein predicted, and we've now confirmed with gravitational wave detectors. It shows that Earth's orbit isn't a fixed track, but a live negotiation between our velocity and the sun's pull. Take one side away, and the deal is off. And most importantly, it shows just how much we owe to a single, ordinary star. The sun isn't special. It's a G-type main sequence star, one of billions in our galaxy. It's not the biggest, not the brightest, not the most dramatic. Cosmically speaking, it's average. But that average star holds 8 planets in orbit. It drives the water cycle, the weather, the seasons. It powers every plant, which feeds every animal, which feeds you. And yes, it feeds Cosmo. Every single kibble Cosmo has ever eaten exists because the sun made photosynthesis possible. Cosmo's entire life, every nap, every belly rub, every stick he's fetched was powered by a nuclear furnace 93 million miles away. Every sunrise you've ever seen is a delivery. Energy sent from 93 million miles away, arriving 8 minutes later, right on time. And it's been doing this for 4.6 billion years. Not once late, not once missed. So, what if the sun just disappeared? 8 minutes of borrowed time, then darkness, then cold. Earth flung into interstellar space at 67,000 miles per hour, a frozen rogue planet drifting through the galaxy with its moon. But even then, geothermal heat would persist. The ocean floor would stay warm. Life around hydrothermal vents would keep going, completely unbothered. And if humanity had enough warning and enough nuclear reactors, some of us might even survive. We wouldn't thrive. We wouldn't rebuild civilization as we know it. But we'd exist, stubborn, shivering, and alive. Max sits in the bunker. Cosmo curls up at his feet, warm despite everything. Outside, the stars drift past, an entire galaxy that used to have a familiar sun somewhere in it. Max reaches down, scratches behind Cosmo's ears. "We used to orbit one of those, buddy." Cosmo's tail thumps once against the floor. He doesn't understand, but he's here. And right now, that's enough. The sun isn't just a star. It's the reason you exist. And right now, it's 93 million miles away, doing its job, asking nothing in return. Maybe look up tomorrow morning, just for a second. It earned that much. Next time, Max and Cosmo are shrinking, way down, past atoms, past quarks, to the smallest possible size the universe allows. And Cosmo is going to try to eat a quark. It's not going to work.